Hello Flat Earth researchers, debaters and debunkers. This is going to be a quick and simple demonstration of perspective, one that's pretty obvious, but one that has to be pointed out because so many people are still denying that perspective is a thing and are really trying hard not to get it. So just showing here that from the side, this external reference frame of these bottles on the table, we can see very clearly that they are all the same height. Yeah. Now you can imagine that these bottles are, say, electricity pylons going across Lake Pontchartrain, if you like, or you can imagine that the tops of the bottles represent a sun traveling above the flat Earth at a consistent height. Yeah, we have this external reference frame, which with the ball Earth we have to imagine anyway, so just apply some more imagination to this little scenario, but take note of the two observations that have to be made here if you want to prove curvature. Okay, we see that they're all the same height, yeah, on this flat, smooth surface. A man-made surface, which you will not find in nature. Of course, roads and lakes and sea is rugged in its nature and it's affected by temperature differences, etc. So no, we are not going to see the bottoms of these bottles disappear over this short distance on a very smooth surface indoors. Okay, there are many other factors involved in these observations, but what we're looking at here is perspective and how we should be making scientific observations if we want to prove curvature. Yeah? So we know that these are all the same height, but of course when we come over here we see this dramatic change in perspective. Yeah, they all appear to shrink towards the end of the row there. Yeah, so if I just put the camera down here, we can make a few more observations as well. Yeah, people talk about angular size, and yes, there are angles. There is an angle at which these bottles appear to be descending towards the horizon. There is also an angle at which the flat surface appears to be rising up to eye level. Yeah, it might not be precisely eye level because the table's not very long and we have a wall in the way, but you can see that I have to raise my hand an inch or so to bring it in line with the end of the flat table. Yeah, so this shows us that the flat surface appears to rise to eye level due to perspective. Yeah, just as the bottles appear to get shorter and to converge at the horizon due to perspective. Yeah, and if the table was infinite and the row of bottles was infinite, you know that we would just eventually get this blur and distortion and we wouldn't see the end of it. Yeah, and of course if we are outdoors, we've got weather, we've got clouds, we've got distortion from temperature differences coming off the surface, we've got haze, dust, what have you. There is a limit to how far we can see physically. And again, if we think about clouds, when we see clouds going off into the distance, those clouds are not too far off into the distance before they appear to meet the surface of the earth or the water. Yeah, so this gives us an idea of really how far we can see, which isn't really that far. And again, all depends on conditions. Yeah, but it's very simple. So here is the kind of observation that we usually make from this internal frame of reference. Yeah, this is what the observer sees, whether the tops of these bottles are celestial objects or the bottles are pylons, whatever, things that are the same height will appear to sink towards the horizon, and the surface, a flat surface, will appear to rise to the horizon, and the horizon will be our particular eye level. Yeah, that's where the horizon will be. Yeah, so when you make these observations of alleged curvature, you've got this one from the observer's perspective, and then to be scientific about it, you will then have to go and get a side-on view of that alleged curvature. Okay, so if you're claiming that a ship is going down a curve a few miles in front of you, then all you have to do is go a few miles in the other direction and get a side-on view of this alleged curvature. Yeah? It's not going to happen, it's not been done, never has been done, and will never be done by anyone trying to defend the globe, because all you will get is this. When you look across at a mountain range that might be hundreds of miles across, this is what we see. But of course, if we were to then get into this point of view, everything appears to shrink over distance. Yeah? It's really simple, but these two observations are necessary if you're going to be scientific about your claims of curvature. One of the observer's perspective and one with this external frame of reference, or a view of what the observer is seeing. Yeah? And then you will understand that perspective is the imaginary curve. Thank you very much.